Coming up on SpaceTime, Ingenuity cleared for flight following an earlier mishap, more delays for Boeing Starliner spacecraft, and how NASA uses radio waves to study the gravity of distant worlds. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's Ingenuity helicopter has taken to the skies of the Red Planet again following its sudden unscheduled landing last month. The tissue box-sized rotocopter performed a short hop to help mission managers back on Earth better understand why its previous flight was interrupted. The 25-second straight up and straight back down again hop provided data that could help Ingenuity teams determine why its 53rd flight ended so abruptly. Flight 53 had been planned as a 136-second scouting flight dedicated to collecting imagery of the surface ahead for the Perseverance rover's next scouting mission. The complicated flight profile included flying north for 203 metres at an altitude of 5 metres and a speed of 2.5 metres per second. It was then supposed to descend vertically to 2.5 metres, where it would hover and obtain imagery of a rocky outcrop which scientists wanted the Perseverance rover to study in detail. Ingenuity would then climb straight up to 10 metres again, allowing its hazard divert system to initiate before descending vertically for a touchdown. Instead, the helicopter executed the first half of its autonomous journey, flying north at an altitude of 5 metres for 142 metres. But then a flight contingency program was triggered and Ingenuity automatically landed. The total flight time was just 74 seconds. Ingenuity team lead emeritus Teddy Zaintos from NASA's Jet Propulsion Laboratory in Pasadena, California, says that ever since the very first flight on the Red Planet, he's always included a program called Land Now that was designed to put the helicopter back down onto the deck as soon as possible if any one of several dozen off-nominal scenarios were encountered. He says that during Flight 53, Ingenuity encountered one of these anomalies and the helicopter worked as planned and executed an immediate landing. The Ingenuity team believe the early landing was triggered when image frames from the helicopter's navigation camera didn't sync up as expected with data from its internal measurement unit. The unit measures Ingenuity's acceleration and rotational rates, data that makes it possible to estimate where the helicopter is, how fast it's moving, and how it's oriented in space. Now, if all this sounds familiar, it's because this wasn't the first occasion on which image frames were dropped by the helicopter's navcam during a flight. Way back on May the 22nd, 2021, multiple image frames were dropped by Ingenuity, resulting in excessive pitching and rolling near the end of Flight 6. After Flight 6, the team updated the flight software to help mitigate the impact of dropped images, and the fix worked well for the subsequent 46 flights. However, on the last flight, Flight 53, the quantity of dropped navigation images exceeded what the software patch allowed. Zentos says that while he hoped to never trigger a Land Now event, the flight was a valuable case study that will benefit future aircraft operations on other worlds. He says with a better understanding of what occurred on Flight 53 and with Flight 54's success, he's now confident the 1.8 kilogram chopper is ready to fly again. Ingenuity, of course, began life on Mars as a technology demonstrator. It was only designed to last for about 4 or 5 flights. Its first flight was back on April the 19th, 2021. It flew vertically for 3 metres and then hovered for 30 seconds before landing again. 4 more test flights in as many weeks added 499 seconds and saw the helicopter flying horizontally over the surface for 357 metres. After proving flight was possible on Mars, Ingenuity entered an operation demonstration phase in May 2021 in order to show how aerial scouting could benefit future exploration of Mars and other worlds. This report from NASA TV.
We'll send the helicopter up to take photos of terrain that the rover might be driving over in the future. The Ingenuity helicopter doesn't look exactly like a helicopter like you might see on Earth. It's sort of the shape of a tissue box with 4 long spindly legs, and it has a pair of rotors above the main fuselage that are far wider than the helicopter itself. These 2 rotors allow it to generate a lot more lift than you would need for an earthbound helicopter. because the air on Mars is so thin and that we need to push really hard to actually be able to get up into the air. There's a lot of work that goes into flying a helicopter on a different planet. We have a system of radio dishes called the Deep Space Network, and we use those to send commands and receive data from the different rovers that we have on Mars, and the Perseverance rover is sort of the parent of the Ingenuity helicopter, and all communications with the helicopter goes through that rover. There's a lot of work that goes into looking at the data coming in from the rover and from the helicopter to assess, is the helicopter healthy? Is it ready to go? Does it have enough power for another flight? We look at that data and we're able to put together a plan of what we want to do for a given day. Once we have that plan put together, we're able to write a sequence of commands that walk it through step by step of what to do, and then we send it on up. When we look at Mars, we can see a lot of preserved history that we don't see on Earth. On Earth, we have all of these processes, rain and waves, and all sorts of different things that mulch up the ground and change it. On Mars, the rocks are pretty much the same as they've been for millions or even billions of years. And we can see far deeper into Mars's history, which can teach us a lot in turn about Earth's history.
This is SpaceTime. Still to come, more delays for Boeing's new Starliner spacecraft, and we study how NASA uses radio waves to determine the gravitational fields of distant worlds. All that and more still to come on SpaceTime. A NASA press conference has now confirmed that Boeing's troubled CST-100 Starliner spacecraft won't fly crew to the International Space Station until at least March next year. After a long series of delays, Starliner was meant to undertake its first manned mission during the first half of this year, but that was repeatedly bumped back. Flight engineers were concerned about two issues. They were worried about the parachute system. Soft links in the parachutes needed to be reinforced with Kevlar and stronger stitching applied. And they were also concerned about the glue being used on the insulation tape, which is used in the spacecraft's wire harness system. It was found to be flammable under certain conditions. And that meant a massive task of removing and replacing electrical wiring where possible and covering other areas where this wasn't possible. Boeing Vice President and Starliner Program Manager Mark Nappi says that at the moment, based on current plans, he's anticipating that the spacecraft will be flight ready by March 2024. But he puts in a proviso, pointing out that launch date will depend on constraints with the space calendar and be decided together with NASA as well as the United Launch Alliance, which will provide the Atlas V rocket that will carry Starliner to orbit. It's been a long and much delayed road for Starliner. Its first unmanned test flight to orbit back in 2019 failed to reach the space station after the spacecraft began its orbital insertion burn too early and too low, in the process using too much fuel, all due to a badly planned and programmed mission clock. Later, engineers discovered that even if the spacecraft had made it to the space station, a software glitch meant it wouldn't have been able to dock anyway. Worse still, the spacecraft would have been destroyed during its re-entry phase due to another faulty computer program. This one would have caused Starliner's service module to fly into the capsule rather than away from it after being jettisoned. Luckily, mission managers spotted that error in time and were able to uplink a correction. A second unmanned test flight to the space station had to be scrapped after engineers detected corrosion in the orbital maneuvering system valves, forcing an expensive and time-consuming strip-down and rebuild. The company finally succeeded in reaching the space station with its unmanned test flight in May 2022. But because of all the earlier problems, scientists and engineers have been going over the spacecraft in minute detail before it's man-rated. It's all quite a contrast to Boeing's rival company SpaceX, which has been reliably flying crew to the space station aboard its Dragon capsule since 2020, and sending supplies and equipment aboard a cargo version of Dragon to the space station since 2012. And Boeing aren't alone with their problems. Sierra Nevada's Dream Chaser winged lifting body spaceplane, which has been contracted by NASA as a third cargo transport system to the space station, is also years behind schedule. The Dream Chaser design is based on NASA's HL-20 manned spaceplane concept, which in turn is descended from a series of test vehicles, including the X-20 Dinosaur military manned spacecraft, which was designed to be launched into space on a Titan II missile. There are also several Northrop and Martin variants, all based around the same winged lifting body design. Dream Chaser was supposed to start delivering cargo to the space station several years ago using an Atlas V to reach orbit. But because of ongoing delays, it's now not expected to fly until at least next year. And that'll be after the arrival of the new Vulcan Centaur launch system, which replaces the Atlas V. At this stage, a manned version of Dream Chaser is still planned to fly by 2025. It'll carry crew to a proposed commercial space station called Orbital Reef, and of course will be available to transport people to the International Space Station as well, if NASA so desires. We'll keep you informed. This is SpaceTime. Still to come, how NASA uses radio waves to study distant worlds in deep space. And later in the science report, a potential internet and power security threat posed by using Chinese-made solar panels and inverters. All that and more still to come on SpaceTime. NASA's Deep Space Communications Network is a collection of giant radio antenna dishes used to communicate with spacecraft traveling to the moon and beyond. But it can also help scientists undertake scientific investigations, such as studying a planet or asteroid's gravity and density. You see, when a spacecraft reaches its destination, it uses radio antennas to communicate with the Deep Space Network, which in turn transmits radio signals back to the spacecraft. Every spacecraft travels in a predetermined path, emitting radio signals as it orbits around its target. Scientists and engineers can infer a spacecraft's location and exactly how fast it's going by measuring changes in the spacecraft's radio signal frequency. This is made possible because of the Doppler effect. It's the same phenomenon that causes a siren to change pitch as it travels towards you and away from you. The sound waves are compressed as they come towards you, and they're progressively expanded as it moves away from you. Electromagnetic waves do the same thing. In this case, the Doppler phenomenon is observed as the spacecraft and the Deep Space Network antenna move in relation to each other. The differences between the frequency of radio signals sent by the spacecraft as it orbits and the signals received on Earth give scientists details about the gravitational field of the celestial body that the spacecraft's orbiting. For example, if the gravity is slightly stronger, the spacecraft will accelerate slightly more. And if the gravity is slightly weaker, the spacecraft will accelerate slightly less. The amount of gravity the spacecraft's feeling can be determined by the density of the material it's flying over. By developing a model of a celestial body's gravitational field, which can then be mapped as a gravitational shape, scientists and researchers can deduce new information about its internal structure. The Deep Space Network is developed and managed by NASA's Jet Propulsion Laboratory in Pasadena, California. Its antenna complexes are located at Goldstone, California, Madrid, Spain, and at Tidbinbilla, just south of Canberra. This report from NASA TV.
NASA has dozens of robotic spacecraft exploring our solar system and beyond. Scientists and engineers communicate with and navigate faraway spacecraft using the Deep Space Network, NASA's international collection of giant radio antennas used to communicate with spacecraft at the moon and beyond. But the Deep Space Network, or DSN, is more than just a messaging service. In fact, scientists use the DSN to perform radio and gravity science experiments. But what is radio and gravity science, and how can it help us learn more about the planets, moons, and other small bodies in our solar system? We're all familiar with gravity. It's the force by which an object attracts other objects, such as a planet pulling a spacecraft toward it. Gravity is also the force that keeps all of the planets in orbit around the sun. Here on Earth, we experience this every day. If you drop an object, it will accelerate toward the ground because Earth's gravity causes it to fall faster and faster. And the acceleration of a spacecraft toward a planet depends on the mass of the planet. Less mass means less gravitational pull. These properties of gravity, combined with our understanding of radio waves, help us use gravity to study other planetary bodies in our solar system. After reaching its destination, a spacecraft uses radio antennas to communicate with the deep space network on Earth, which in turn transmits radio signals back to the spacecraft. Every spacecraft travels in a predetermined path, emitting radio signals as it orbits around its target. Scientists and engineers can infer the spacecraft's location and how fast it's going by measuring changes in the spacecraft's radio signal frequency. This is made possible by the Doppler effect, the same phenomenon that causes a siren to sound different as it travels towards and away from you. The Doppler phenomenon is observed here when the spacecraft and the DSN antenna move in relation to each other. Differences between the frequency of radio signals sent by the spacecraft as it orbits and signals received on Earth give us details about the gravitational field of a planetary body. For example, if the gravity is slightly stronger, the spacecraft will accelerate slightly more. If gravity is slightly weaker, the spacecraft will accelerate slightly less. By developing a model of the planetary body's gravitational field, which can be mapped as a gravitational shape, scientists and researchers can deduce information about its internal structure, all while using the Deep Space Network.
This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has confirmed that extreme events from climate change have influenced every realm of Antarctica, including breeding failures for entire penguin colonies, ice shelf collapses, the invasion of non-native plants, and the recent lack of winter sea ice. The findings, reported in the journal Frontiers in Environmental Science, have for the first time brought together a new synthesis of evidence looking at how extreme events have affected the ice continent. The authors conclude that fossil fuel burning will continue to affect the Antarctic environment, and countries which have adopted the Environmental Protocol for the Antarctic Treaty must ask themselves whether their greenhouse gas reduction targets put them on path to enable true protection for Antarctica. The World Meteorological Organization says China remains the world's biggest carbon dioxide polluter, producing almost a third of the total global output, amounting to more than 10.1 million tons annually. That's almost double the amount produced by the United States, which is in second place, and 4 times the amount produced by India, which is the world's third worst polluter. They're followed by Russia, Japan, Iran, Germany, Saudi Arabia, Indonesia, and South Korea in 10th place. Next comes Canada, Brazil, Turkey, South Africa, and Mexico, with Australia in 16th place, followed by the United Kingdom, Italy, Poland, and Vietnam rounding up the top 20. A new study claims hepatitis C patients who are cured of the infection still face a 4-fold higher risk of death than the general population. A report in the British Medical Journal looked at the health outcomes of 21,790 patients who were cured of Hep C using interferon-free antivirals. They found that 1,572 of the patients died during the course of their study. And the researchers said the rate of death among the group was much higher than that of the general population across all studies. They say the most common cause of death was drug-related liver failure or liver cancer. They found those whose livers were more damaged at the time they were cured had a higher risk of death than those whose liver disease was less severe. The Australian government has raised concerns over the potential internet security threat being posed by using Chinese-made solar panels and inverters which use Chinese chips to connect to power grids and the internet. In Australia and around the world, Beijing dominates the solar energy market, controlling some 76% of all solar panel sales globally. A review of solar panel systems in Australia found nearly 60% of smart inverters, which connect solar panels to the power grid and the internet in Australia, are also made by Chinese firms. And that means they fall under Beijing's strict national intelligence laws. Federal opposition energy spokesman Ted O'Brien says the inverters could be taken over by Chinese officials for sabotage or for spying purposes. O'Brien says energy security is national security, and providing affordable and reliable energy that's free from foreign interference should be a first-order priority for government. He says nothing's more important for a government than guaranteeing Australian security, and the electricity grid is central to that. Meanwhile, Opposition Home Affairs spokesperson James Patterson, who oversaw the review, says the number of inverters in the energy grid will continue to grow thanks to the government's renewable energy target of 82% by the end of the decade. Patterson warns the current situation has left the energy grid vulnerable to potential foreign attacks. He says the real danger point will come when these products reach a significant proportion of Australian rooftops, and therefore a significant proportion of the energy grid. He says at that point they could be remotely disrupted by an agency like China's People's Liberation Army State Security Cyber Hacking Unit. The problem is it's virtually impossible to buy Australian, European or American-made solar panels and inverters in Australia, despite Australian research being used in the development of the current technology in the first place. A spokesperson for Home Affairs Minister Claire O'Neill points out that Senator Patterson and the opposition need to explain why they turned a blind eye to the procurement of these solar panels from high-risk vendors for over a decade while they were in government. This week, Alex on Tech looks at Dyson's new noise-cancelling headphones, which come complete with a built-in air purification system. We look at the latest stats on Australian gamers, who are they and what are they playing, Elon Musk's latest moves to get inside your brain, but we begin by looking at the continuing battle to beat the online crooks and scam artists trying to rip you off. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Well, the Australian government is reporting through ACMA that over 1 billion scams have been stopped over the last 12 months. And in the last quarter, that's 256 million scam calls and 85 million scam texts, but they're still coming through. But the scams stopped in the last quarter are 33% greater than for the same time last year. So, look, they are having some success, but the bad guys just keep trying.
Well, it's just a numbers game, isn't it? They'll try a gazillion times, and all they need is one to get caught, and it's been worth it for them.
That's right. And, you know, people are busy. They've got kids. They've got work. They've got all sorts of things happening. It's easy to make a mistake, to click on a wrong link, to pay something thinking that it's real, and the next thing you know, you've been scammed. So you definitely have to be super vigilant and not trust anything you get on text messages that you weren't expecting. And even if you do think you're expecting it, double check. Okay,
let's move on to the big E, Elon Musk. We know him from Tesla and SpaceX, and he's also got a company called Neuralink. What's that about?
Well, Neuralink is to create a general purpose, high bandwidth interface to the brain. And it's just raised in the past few days $280 million. And this comes after the US Food and Drug Administration, the FDA, has greenlit the company's work to implant Neuralinks into human brains. Now, they've already implanted them into pig brains, and there's a video at my website, techadvice.life, on the article about this where you see a monkey playing the game Pong, but he's doing so completely with his brain. He's not controlling a gamepad in his hands or anything like that.
Is it actually inserted into the brain, or is it kept on the outside of the skull and it's just picking up and sending signals through the skull and into the soft tissue?
Well, in 2020, Neuralink implanted a chip into a pig's brain, and in 2021, another chip was implanted into a monkey's brain.
Right, so
and again, you can see
inside.
Yeah. So it's not wireless. Let's put it that way.
I'm assuming that means he's solved the problem of corrosion with the chips and the problem of infection as well.
Well, look, I think I'd say it's all being tested. I mean, he only just received FDA approval to test this inside of human brains, but yeah, that would have to definitely be one of the things to look out for. You don't want to infect your brain with some sort of bacteria or disease just because you have a chip inside. But this is something that any kind of implant in the human body would have to deal with. Whether it's a chip in your hand, people have implanted RFID chips into their hands, whether it's a pacemaker in your heart. So
it's worked okay for Steve Austin, hasn't it?
Absolutely. Yes, the $6 million man.
People of a certain age will understand what we just said.
Absolutely.
Okay, 4 out of 5 Australians play video games on a regular basis. This comes as no surprise to me, as you'd expect.
Yeah, so 81% of all Australians are playing video games, up from 67% last year, according to the Interactive Games and Entertainment Association from their latest Australia Plays 2023 report. And they say that they're using games to improve their mental health, and they prefer puzzle games over action games. Now, puzzle games, it's sort of you're actually achieving something more than just wiping out hordes of aliens or other soldiers. 94% of Australian households have a device for playing video games, up from 92%. 76% of game households have 2 or more devices for playing games. 48% of gamers are female. More women and girls are playing than ever before, up from 46%. After age 55, Australian women are playing more video games than Australian men. 35 years is the average age of video game players in Australia. 75% of Australians play video games with others, and 91% of parents play with their children to connect as a family.
Dyson's officially launched its new noise cancelling and air purifying headphones. Are these the same air purifying headphones we talked about a couple of months back?
Well, actually, they launched this to the world a couple of days before April Fool's last year, and a lot of people wondered whether this was an April Fool's joke. And they said, no, they swore black and blue that no, it's actually real. And it's called the Dyson Zone. In Australia, the standard version will sell for $999. So around about the same price as Apple's AirPod Max headphones and sort of double the price of what you pay for the Sony or the Bose equivalents. But because Dyson has had such a long history in having these motors and also air purification, they've been able to, in the cups that go over your ears, they've got some fans in there that are spinning around. And not only is there 50 hours of listening time, despite the fact they have to spin, and we've got 11 microphones, a number of which are used to reduce noise pollution by up to 38 decibels, but it's also purifying the air with particles removed as small as 0.1 microns, and activated carbon filters absorb gases such as nitrogen dioxide from urban pollution. So when you're walking down the street, a lot of the pollutants from the various cars, in theory, that'll all be filtered out, and you have this visor that you can remove. You don't have to have it. You don't have to have the air purification on if you don't want it.
And yet another big story, and what's been a big week for tech news, is the idea of almost weekly updates for beta iOS 7.
Yes, look, that's normally around about this time is when Apple starts launching weekly updates, because there's only 4 or 5 weeks to go before the new iPhones will be launched. And of course, iOS 17 has to be ready. So there's a new PB3, Public Beta 3, as we speak, and a Developer Beta 5. And hopefully, this time next week, we should see Developer Beta 6 and Public Beta 4, and which will make a lot of people who are actually using the betas every day on their primary devices very happy. For me, I've just installed it on a secondary device. And also, we have betas for the Watch, the Mac, for HomePods, for the tvOS. Again, unless you're really keen and you can put up with bugs, don't install these yet. Wait for the final version. It's just a few weeks away.
That's Alex Zaharov-Reutt from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.